Hi and welcome. So again, we're back with yet another welding fixture, except this one's to replace one I already made. So if you remember last video, we made a fixture to weld these seams together. This material, I didn't know at the time, is actually Inconel, so very expensive. It's 12 thousandths thick. They want it to end up round, so we created a semicircular vise jaws that pressed this guy together very lightly, and they welded the seam. Well, turns out there was a problem with that approach. And here's the weld, which unfortunately blew out the ends. Normally, for a lot of the products, when you're going to do thin material like this, they have tabs that stick out so you can start off the material where you want it, weld through, and finish off the material on the other side, so you don't have issues with blowouts like this in the part you want to keep. So that was a design fault of the manufacturer, and they probably should fix that. I don't know if they're going to, but you can see the vise jaws were pressing gently. I asked the guy who was doing the welding, an expert, if you couldn't just let them lightly almost touch. And he said with thin material like this, you just blow holes through like the end there. So you have to put a little bit of pressure on it, not a lot, but it made it go egg-shaped, which you can see there. And egg-shaped is worse than flat. So here's the rough piece. So they brought me this seam welding fixture here that is very adjustable. I think it was done in-house, I don't know for sure. And it's very adjustable. You can adjust the spacing of these, longer or shorter. It's got a flat on top, so these little press plates press on the flat and the material. So it's gonna actually make it flat instead of sticking up. And my contact said that that would be a lot better choice because it's a lot easier to fix. This is probably the complete wrong dimension now, he was concerned about anyways. I guess to start with, we're gonna put a thumb screw on this guy because that bugs me. And I don't know if you've seen these before. This is a standard cap head Allen screw. And these are press-on knobs for them. And they actually work really well. They engage both the outside and the inside of the hex. So you just take them to a vise and you just press this guy on and voila. You've got yourself an instant thumb screw. They actually survive pretty well. So we'll replace that, that kind of bastardized solution over there with a fixed version. So now onto this bit. We need to make a new copper mandrel because this one is 700 thousandths or so in diameter, a little more I think. It was originally 3/4, but it's just under 3/4 now. Put a flat spot. We got to add a new spigot on the end for gas. They just had a barb on this guy, by the way. So let me take this off here too. So this design's kind of neat. This copper bar, these are 650 thousandths thickness here to here and here to here. And so they just fit a little bit interference fit, just very ever so slightly on the one side, not at all on the other side. The flat is level with this right here, which is where these copper plates lie flat on. So that slides over and can press on the part very nicely. These parts obviously are a lot shorter than this long mandrel. Well, this thing was designed to be adjustable as well. So I'm going to pull this plate in so that we don't have to use so much copper. Copper is over 10 bucks a pound at my local supply place. It's been going up almost weekly. Aluminum has gone up as much as 10 cents a pound in one day because of the tariffs. So I asked them about it and they said, yeah, wait till you go and buy some aluminum. Aluminum has gone up vastly since last year because we don't make a lot of aluminum here in the United States. And what we do use is not, like rounds and bar and things like that. So unfortunately we have to import it all, which means we're gonna have to pay tariffs until they get around to building a manufacturing plant here in the United States, and God knows how long that'll be. So in the meantime, we just gotta eat it. So we're going to reproduce this copper bar in a smaller form factor, smaller diameter, because the internal diameter of this is 690. I made the last one 680, and he said it got a little bit too tight. That's probably because it went teardrop shaped. So we're going to go for 670. That'll give him 20 thousandths clearance. That's actually quite a bit. And because it's a smaller diameter, one of the ends I'm going to leave full diameter. And that way I can just take off the material and make it match this so it sits right. The other side, I'm gonna have to build some sort of shim that's gonna fit in here that will hold this up properly and in the center. So we're gonna have to work on that too. And I think that's about it. I really like the design of this fixture. Whoever does their fixture design does some really creative stuff. These pieces just pop right out of here, and I could make a new one of these as well, except that I think it would take more time and effort to make this guy than it would to make a whole new shim. But I don't know. This is certainly doable. I could make just one side, keep the one side intact, and remake the other side. That could be. It's just a beautifully done part. Anyways, I'll figure that out as I go. I'm going to start by making the bar, and then we'll work over to whether I want to build a little U-shaped spacer in here or want to remake this piece. All right, so I moved over, found a position where this fits inside, but still has a little gap. When I went to the next one over, it just barely fit in between there, and that seems too tight. So we're going to give them a little slack, so we'll make it right here. Now I can just flip it over and tighten the 2 bolts on the bottom, and we can continue. Another thing, when I return, I'm going to put a washer under each one of these guys. They were probably that way in the beginning. I don't know why they lost them, because you really don't want to snug this up against the aluminum. It'll score it. Plus, it'll likely want to make it move. So this is going to be a pretty tight operation. We're only leaving like an 1/8 of an inch gap in there. I bought the shortest pre-cut piece of 3/4 copper bar. This is 110 copper. By the way, if this were, if this were a cutoff piece, which is like half price, this is $10.40 a pound. The cutoff remnants were something on the order of $5.20 a pound, like half, almost exactly. Or that is exactly. If it was beryllium copper, wouldn't touch it. Don't want beryllium in my shop, won't work on it. I got a big job offer to do a bunch of parts with beryllium copper. The risk to yourself is way too high to make it worthwhile, especially for a hobbyist like me. Beryllium copper can cause berylliosis after a single exposure if you get unlucky, but multiple exposures make it much more likely still. And berylliosis basically is a terminal lung condition that will, your lungs get hardened and you can't breathe, and you basically ultimately die of it, I believe. Anyways, something to be avoided at all costs. This is 110 copper, which is 99.98% pure. This little bar you see here is 3 feet long and costs, I think it was like $58. Anyways, so let's figure out how much we need. I want to stick out this end, so we're going to go for 10.5 inches. Cut ourselves off a piece. All right, first up, we need to drill a center drill hole in this guy, because we're going to reduce the diameter down to 0.570 inches, just over half an inch. This really is gummy stuff. Jeez. Double checking to make sure I don't have any taper in the bar. It's pretty good. Rotationally, this center is plus or minus 1.5 thousandths, which is plenty good for this. This mandrel doesn't actually make contact with anything inside. All right, let's see how copper performs. We're going to try 25 thousandths. Go for a pretty high feed rate initially. Makes me wonder if I should be setting this copper aside like you would gold dust or platinum if you're working on a project with that. Slowed my feed rate down, increased the speed because of the diameter shrinking, and doing my second to last pass. This is all the copper I've removed. I feel like I need to recycle that. Final pass. Taking off about 2 thousandths. .5708, 0.5706, 0.5705, 0.5701. So 7/10 taper over 9 inches. That's not bad. And it was definitely not critical, so it didn't matter. My last pass was just a 2 thousandths pass to clean things up. I'm going to put a little chamfer on here to get rid of the sharp edge. Clean up this sharp edge. We're going to have to drill and tap this side for a NPT8, National Pipe Thread 8, and then take this over to the mill. I just realized that I was planning on my next move that I almost made a huge mistake. If I put the hose fitting here and have to slide a thin tube on, you'd have to disconnect the hose every time you need to swap the part. I need to put the hose fitting on the other side. Dope! Almost got nailed there. Now I flip the part around. We're going to put the NPT in this side. I need to reduce this down to 703, 0.703. Almost forgot we need to drill out the center of this guy too. The drill bit I chose here for the small hole has an extra grind done on it so that only the outer part of the flutes actually touch. The inner part's relieved, and I'm hoping there'll be less friction for this material. Threaded 1/8 inch NPT was miserable in copper. It kept gumming up and catching, but we got it. So now we're good to go here. Now it's just on over to the mill where we can mill all the flats. All right, so now we have the whole thing loaded in the vise here, just on a single parallel. And I want the flat on top to be 1/4 inch to match the other one. So I did some math. Knowing the diameter of this, which is 0.570, you can draw a 1/4 inch chord across here and figure out what the depth would be. If you're interested in the math, let me know. A lot of times I show math and I don't think people are very interested in it, but I can show how you can get there from just knowing that value if you're interested. So let me know in the comments, and if you are, I'll show you. Once I knew the depth to go down, 29 thousandths, I just found my peak roughly. I mean, none of this is super precise, so it's all good. And set my depth 29 thousandths. We're just gonna make a pass right on over. Trying to decide what to do next. Originally I was going to do flats on all 4 sides of this one like the original, but I realize now I don't need to do that. I only need to do 4 flats on the big one that will register with one of the end pieces, because that will set my orientation, because you want to have this exactly vertical, and if it's round you could rotate and you wouldn't necessarily be vertical. But I only need to do it on one side, and that'll automatically align the other side as well. That seems like a decent idea, so I think I'm going to do that. So I should drill the hole now since I've got this oriented properly. So we're going to drill a small hole in here. This is one of those faster is better. And we're in. It's always nerve-wracking dealing with those solid carbide drill bits that tiny. They are so prone to breaking. Since I'm always interested in trying new things, I think it's worth having a center line to show them where to line the part up. So I'm going to try this very small end mill. I don't know what the diameter is. And we're going to just do a 5/1000th depth of cut. See if we can get away with it. I break 1/8 inch end mills left and right. This one's a whole nother level. So we're going to go max speed. Threw up a really nice burr the whole direction. This is soft, gummy, nasty stuff. All right, so now that we've done the flats on this side, we're just going to do the flats on this big part over here, and just on the two sides. The bottom won't need one because the sides will get the orientation correct. So we'll use this flat here to help orient the sides and get that dimension correct. All right, so we're good to go. The fit is nice. There's a little tiny bit of slop, but not too much. Orienting these two bars so they're in line with each other is a bit of a challenge because you got to get the spacing from here to here correct, as well as perpendicularity or parallelism between these two plates. So this one needs to be shimmed up 30 thousandths on the bottom. That's it. This one needs 91 thousandths on the bottom and 51 thousandths on each side. I'm not quite sure how I'm going to pull this side off yet. This side maybe just some shim stock. I'm not exactly sure. I mean, I could rebuild these entire pieces, but that would be very time consuming. I've decided that making small shims to fit these things is going to be too difficult, especially when you need to do three sides with different thicknesses that are all really thin. So it's going to be very delicate. So I decided I'd remake these parts. I don't know that I'm going to put these cute little 45s on here because they're not really necessary, but we're going to remake this part here so that with these two blocks, and that way we won't need, actually technically only need to make one of the blocks because I can shim up one of the sides without a problem, but the other side is going to be too difficult to do. So we're going to do this part first, and I figured I can just cut straight through here, make it easy. Last finishing pass, I'm leaving a few thousandths on the floor to clean up at the end. We got to make this slot wider, so we're going to come back and hit that. I got to remember to do climb mill on each side because I got to move the end mill out on each side, take off some additional material. Cut the relief on this side. Now we're going to do these two, this side, and then the bottom side last. This side here is the top. All right, so that made us good to go. I think we need to take these corners off like the other ones were, simply because they're actually having issues bottoming out, and I think that's because this corner can't fit where it needs to go, so you need to relieve it. All right, so let's cut the 45s. Got some 45 angle blocks here, and we're going to do the inside because everything's set up for the inside, and I know the offset in each direction I can go without hitting the outside. So we're going to do the 45s first on the inside with two passes. I just got to figure out how much I want to take off. I don't want to take off as much as they did. So we're going to do this side, then we're going to flip it 180, do that side, then do the same for this block. And we're good. Now we just need to machine our reliefs here for the part to go in. The whole point of this, everything we've just done. We're going to start for the relief for the small end first over here. And that'll be 0.57 wide, 0.541 deep. Then I need to do the final depth with the same measurements here. You notice I'm going like this because I want it to be a climb cut each time because I want the surface finish to be good. We swap places, time for the second one. We're looking for a depth of 0.604 on this one. All right, so here we are at the finish line. Here's the new pieces. The old pieces are right here. I like how they finished them. That looks like either a sodium hydroxide finish where you put sodium hydroxide on the aluminum and let it etch slightly in the surface, or a pretty smooth sandblast. So we got the small one on this side, got the big one on this side. This guy will go here, which is nice, good fit. This guy will sit somewhere. I don't know if they want, I don't know which way they're going to want it, but I'll put it like this for now. Oh, you know what I forgot? Forgot to put this guy on here. There is a hex down the middle of this, an Allen, so you can tighten it on. So I'm going to loosen this end, see if I can get it to line up just a little bit better. There we go, that's much better. Well, I got a little bit hosed here because these copper bars actually don't sit flush on the aluminum plate like I thought they did. So what I did not notice is that when these hit bottom, these little rails here hit the bottom, the copper is still 30 thousandths over this. It looked to me like when I was playing around like it was flush, but I missed that, which is unfortunate because I could have just modified this to be 30 thousandths less deep and then it would have been fine, but it's not. So I could just remove material off the bottom of this and that would bring it down and then it would be fine, but that would screw it up for the other ones where I think they're counting on these feet hitting bottom just a little bit after the copper touches. So instead I'm going to shim the copper down. And to do that, I made this adapter plate to sit on top of my bandsaw a while ago. And we got the shear here. And I have some stainless sheet that's 17.7 that's also 40 thousandths thick. So we're going to make some shims. This is not my favorite solution, but it hopefully will work. All right, so we're all shimmed up here. It's pretty hard to get the pieces squeezed together and tighten down all at the same time. Maybe they got a tool to squeeze the round part together and then just tighten it. I tightened one side first and then tried to get the other side. Still, you loosen one, the other one slips out because, you know, you're pushing on a curve and you can't hold it all the way flat because there's not enough torque on these thumb screws. So maybe they need bigger knobs. I don't know. We'll have to talk to the client, see what they think. I think it's pretty challenging like this, and I think the other fixture had more promise, but we'll find out, and I'll keep you updated when I find out more. Thanks for watching. Hope you find it useful. Hope to see you next time.